Hello everyone. So now like we are going to see a problem like from Google Kickstart 2022 round E. This is the third problem. Like I have already solved this first two and like I have already like uploaded in this video. So now like let's go into this problem. So this problem is something called like matching palindrome. So like question is, you are given with a palindrome string P of length n consisting of lowercase letters in an English alphabet. Find the shortest non-empty palindrome string Q such that P concatenated with the Q forms a palindrome. Formally like PQ forms a palindrome. So okay, input consists of TT and test case consists of two lines, n and length of P, the second line. So like you need to print the output. Okay, test cases are like 10 power 3 and 10 power 5. Okay, so what they have given us, they will be like giving a palindrome of length n, palindrome p with the length of n. So you need to find a palindrome within p, and you need to let's say q within p, and we need to concatenate PQ, and then that PQ string should also be a palindrome. That's it. So you need to find a palindrome within P of length yeah, less than n, and then you need to concatenate both the strings PQ, PQ, and then you need to give the palindrome. So if like n minus 1 is not printing, then obviously like n will be like printing. So in this case, we have something called like uh, two cases. One is with n square, and then one is with n log n. So let's go into the problem with this like TLE, like which will fail for test case 2. So obviously like you'll be like getting understand. So we'll explain this question. So we have a string. Okay, let's say we have a string called, let's say this thing, A B C D C D C. Okay, so we'll just take this. So this is a palindrome of length n, which is called as P, palindrome P. So what we need to find, we need to find a palindrome which is less than P, size less than n in this P. So what we will need to check is like obviously like we need to concatenate that it is like the new array should be like PQ, right? Let's say it is PQ. So what will happen is like see, we come to a logic, say like starting here. So P starts from here. Okay, so we'll say this is its 0th index and it is its nth index. So let's say we have this is Q. Q. So for Q, what if this entire thing should be like palindrome, then this 0 should also be here, right? 0. So it can be any number of things. Say let's say I. So it should be like I2 0 to n. Okay, right? So obviously like our starting point should be like a 0th index of P. So that's what our logic starts from. So we let it get. So what we do, we just check with the C, and then we just put this palindrome. Like we take first string as C, and then we add it as CD, CD, and C. So we check whether this is we check this is a palindrome. Or else like we what we do, we take two string, let's say CD next. So we check again for palindrome, and what we do, we take a string of 3. So now we can say that this is a palindrome, right? So see, so this is a palindrome. If we check, it gives a palindrome for true. So our loop starts, I mean, like stops here. So that's what I'm doing. I have done to here. So what I have taken is I've taken n and p for question is 1. So what I will do, I'm taking is like I'm appending like prefix and suffix. So what I'm doing is this prefix should be like it should start from 0 to pause, right? So pause is like the index from starting from 0, I mean 1. Like, obviously, like it should be like starting from 1, no, like this is in Python, right? So 1 means it will be starting from 0 to 0. So my prefix that is this is q, this is q, and suffix that we don't ever need it. So prefix. So what I am doing is so prefix equal to prefix or minus. So I'm just checking whether obviously like q should be also like a palindrome, right? So I'm just checking whether this is a palindrome or and this suffix is palindrome. If both are palindrome, then I'll just return this prefix. So in this check, like we can also do it like this. So this complexity is about n square. So like for n, like I'm passing it to this thing, and for checking palindrome, I'm even getting O of n, right? So it is like n square. So we need to so we also have another logic right here. So another logic is somewhat different. So we can have it one logic one like this, and we can also have another logic like if if so we say like we have splitting it, right? So if we say this q should also be a palindrome, and obviously if I take this q from this p, obviously this new element, let's say r, this r should obviously be a palindrome. So that's what we are checking. I'm doing here is like I'm placing a index pointer like position. So I'm just shifting it one by one and just checking whether this element, these values are strings, mean these strings are a palindrome, and obviously like these things are palindrome. So in which case, whether both are true, I am returning this position and then position, so that I'll give this answer like minimum element, right? So we don't even need this string value, so we need only that length, right? So in this case, like I'm getting a O of n plus O of into O of n, that is O of n square. So I'm getting a test case 2 error. So what we are doing here is, so we use one algorithm called, so in here, like we use one algorithm called Z algorithm, Z function. So this function, so if you don't like remember what, like don't know like what is Z function, I can just give you a startup like what a Z function will really do. So a Z function is purely based on a string that will find a suffix, I mean suffix palindrome from a string. So that's what this Z function will be like doing. So if you want to need a uh, more information about this Z function, you can go through this CP algorithm page, or else like if you need any code or something, you can get it from Gigs for Gigs. It is open source like. So I got this entire function from Geeks for Geeks. So this Z function, what will do? It will return this suffix ID. So it will return this suffix. So how it is like how it will function is. Let's say I'm starting with this. Let's go with any new values so that you can be valid there or any cases. There are cases. So let's say, see, this z function, what it will do, it will just have an array of a length n, that is up to this n. Okay, so it obviously this zeroth index will be like 0. So now what it will do, it will is this z function will calculate for this c first. So if this is means sorry, it will calculate from d. So obviously like it is override. So it will calculate from c. So if it is c equal to c, so it will go for 1. So if c equal to d, right? I'll explain you here itself. So string function will be like, so this is my z function algorithm. This is also on my page. So how it will happen is, so we can have this function here. So it will start from 0th index. So it will compare with suffix 0 until 1. So we just have it like this. So I think I got it. So what it will do, it will compare this C to D. So if it is not C to D, what it will do, this will return a value called 0. So and then it will start from, again we are finding it for suffix, right? So obviously like our base index should start from 0. So it will start from C to C. So it will return 1 here, its corresponding index 1 here, and then it will combine for this D to C. If it is not, then it will automatically with break. So again it will go for this C, and then we'll compare for, sorry, this C and then this C, and it will go for this one, and then it will compare for this D. Sorry, I'm just overwriting. So we will compare with the C and the C now. So we are getting this 1. So and then like we compare with, if this is 2, then it will automatically increment, right? So we will compare with this D and then this D now. So if it is equal, then we increment it by 2. And then if we compare this C with the C, so if it is also same, then we increment it by 3. So obviously, like after this 3, like what we need to do, we can't have it something like the empty spaces, right? So we obviously have this kind of empty spaces. So what we'll do, this will break here, this will break here, and then we compare with this C and D. If it is not, so we return this 0 here, and then this C, this C, so 1 here. So what it will do now, it will give the maximum count, right? So minimum is like 1. Minimum suffix palindrome that is found inside the string is 1. So we can return the 3 because we need the maximum palindrome that is found here, right? We don't even know like what this is here, right? So we are getting it from 3. Okay, so 1 now, like apart from 1 we need to get it right, so we need to get it for 3. So what this 3 will do, we'll go to my code and see. So we will return this z, that array here. So what this array will do is, it will get the minimum n minus 1 p prefix, that is this 3 will be like returning. So this 3, I will pass this minimum length here, and then I will just printing the first 3 letters, that's it. So this case is the time complexity is somewhere like or n log n. So in this case, like Uh, in this case, my code is like getting passed in the both the test cases. So in analyze also, like you can see like they have used something called n root 10, that is n log n on n root 10. Some both are obviously like literally the same, right? So this is also like something called they have used like Manchin's algorithm. So I have used a z function for this. So thank you for watching my video.